Today we're going to look at the unit circle for sine, cos and tan graphs. Now most people have heard about this, they've seen it, but I'm going to explain it, the theory behind it, so it makes more sense, especially when you're working out exact values and the sine, cos and tan graphs. So you should all be drawing this circle in your sleep. The unit circle, as we know, the radius of 1. But we're not going to do that too much for this one. We're going to do this one, where we had a look at the last video, and it's your vertically opposite angles to give theta. And as we did last, 1, 0, 90, 180, 270, and 360. Now this circle is going to be your best friend forever, and you have to write it in your sleep. Every time you go to an exam, every time you look at a question with sine, cos and tan, exact values, you draw this. There's those little magic values, which I call trigger values, that you will see later on. So if we have a look at this, we can use this for so many different things. If we have a look at our sine and cos graphs, you should straight away write these down. Now remembering my little cheat sheet from last week is you write down the degrees and then you write down the radians. Now we know with sine and cos that they have the maximum and the minimum at 1 and minus 1. Now if we go back to have a look at the unit circle, this is 1 and 1 because it has a radius of 1, and we know that when we look at this, if it was on the Cartesian plane, this will be 1, this will be 1, minus 1 and minus 1. And I always like to draw here, if we're looking at these values, the x and the y values. So on this point here, when it's theta is 0, it's 1, 0. This one, when theta is 0, I'm sorry, theta is 90, it's 0, 1. When theta is 180, we have minus 1, 0, and at 270, we have 0, minus 1. And we're going to have a look at that when we transcribe it to the cos and sine graphs. So this all comes down to, if we have a look here, our sine, cos, and tan ratios. Now this you learnt in grade 8. Socatua. Sine opposite of hypotenuse, adjacent over hypotenuse, and opposite over adjacent. If we look at this circle here, there's my theta. We know that's 1, which is our hypotenuse, which is the radius. If we do sine of theta, it's opposite, which this value here is actually your y value, and the hypotenuse is 1. So that's why sine theta is your y value. Let's have a look at sine 0, just to be easy. Sine 0, here the value is 1, 0. My x value, my y value. So sine of theta is your x, which is 0. If we have a look at cos theta is opposite over hypotenuse. So adjacent over hypotenuse. So here adjacent is your x value and your hypotenuse is 1. So it's x over 1, which is just your x value. If we look at cos of 0, the x value is 1. Now we can plot that. There's sine, there's cos of 0. Now what about tan? We know that it is opposite over adjacent. if we go to our little unit circle, opposite is y, adjacent is x, which is really sine over cos. And we all know tan is sine over cos, and that's where it comes from. Well, it doesn't come from, you can prove it. If we have a look at tan of 0, it is the y value, 0 over 1, which equals 0. Note that, and we'll come back to that one when we do 90. So tan is 0 as well. We'll do tan in orange. Now, we'll have a look at sine of 90. We'll do a few. You guys can work it out after that. If we look at 90, that's here. It is 0, 1, x and y. Sine 90 is the y value, which is 1. Cos 90 is the x value, which is 0. And tan 90 is 1 over 0. Now this is a very important part for when you're doing some proofs or you're doing some justification. Do on your calculator 0 divided by 1, you'll get 0. That's why this little asterisk is there. But on your calculator, if you do 1 divided by 0, it's undefined. And that's like if you look at the hyperbola, which is 1 over x. You cannot have x equal 0. So very important part is this is undefined. And if you remember your tan, it has asymptotes here, asymptotes here, asymptotes here. And that's because it cannot equal 0 for that reason. So let's do sine was 0, 1, where am I up to here? 1, cos is 0, and tan is undefined. So we're getting there slowly. Nice and easy. Let's do sine of 180. Again, 180 is here, so it's minus 1, 0, x and y. Now you probably know all this, you can put in the calculator, but in your tech free, you should remember this, and it's also good to help draw your sine and cos graphs. At 180, the y value is 0, so that goes back to here. And as you can see, my sine graph is coming on very nicely. Sine, oops, cos, I'll rub that out. Cos of 180 is your x value, and it's minus 1. So if we have a look, it's down here. So my cos is looking like that. And then your sine, not your sine, your tan, should watch what I'm doing. Your tan of 180 is y over x, which is 0 over minus 1. It's not minus 1 on the denominator, so it's just 0. And again, that one for tan is 0. Now we'll go a little bit more into tan later, but if we know tan, it goes like this. And it will go down like that, and it does the same here. We'll have a look at tan theta a little bit later. So now if we go back to here, we're nearly there. We'll do now sine of 270. And again, we look at the x and the y. 270 is here, so it's 0 and minus 1. Sine of 270 is the y value, x and y, minus 1. So that's your tan. So your sine, my goodness. Let's have a look at cos of 270. That's your x value, and x is 0. So it comes back up to here. Now you can see those nice graphs coming along. Tan of 270 is y over x, which is minus 1 over 0. Again, not going to work, so that's undefined. And another asymptote, which we see there. And the last one is sine of 360, which is going back to 0. And the x and the y again, is 1, 0, x and y. That's the y value, which is 0, and it goes back up. There's a nice little, remembering they keep on going on unless you define the domain. Of 360 is the x value, which is 1. So that comes back up, and it looks like that. And then 10 of 360, look, my writing is getting worse. Try and write a bit neater. 10 of 360 is y over x, which is 0 over 1, which equals 0. And again, if we have a look, we just draw this one going down that way towards the asymptote. So that's just your 0, in 90, 180, 270, 360. And they're using that unit circle. Now they're the ones you can either put them in your calculator and do them, know that, but it's always good to know it. So now we're going to get rid of that one, and we're going to work out the exact values, which I think we will do in the next video. So we might pause there and we'll go on to the next video. Have a look at that one. Make sure you know your unit circle and make sure you draw that every single time. That was for 0, 90, 180, 270 and 360. The next video will be on the exact values of 30, 60 and 45.